This episode of Real Engineering is brought to you by CuriosityStream. Watch thousands of documentaries for free for 31 days at curiositystream.com/realengineering. At the outbreak of the Second World War, the United States was lagging behind many of the other nations in the industry of tank development and manufacture, and their British allies were not much better equipped in the field of armoured warfare. Following the speedy fall of France in 1940 at the hands of the aggressive German advance, they knew they needed to upgrade and develop their weapons and armoured vehicles. Making a new tank model to compete with the very capable German tanks would require it to be agile, well armoured, with rock-solid reliability, have a powerful gun that could take out enemies from all angles, and perhaps, most importantly, to be quick and cheap to manufacture. However, combining all these traits into one tank is no easy task, and in July of 1940, a new medium tank, the M3, was proposed. Intended to be a stopgap solution, the War Department confirmed and authorised its development quickly. And just a year later, the first models were rolling off the production line and shipped to the front lines. The United States wanted a 75mm gun in the turret. However, their engineering capabilities were nowhere near advanced enough to realise this goal in such a short turnover time. Fitting a large gun like this presents numerous design challenges. Chief among these was building a hull capable of supporting it. At this stage, the US did not have the equipment needed to build a large turret ring, and the technology needed to cast a hull strong enough to bear a large turret. And thus, the M3 Lee was produced as an interim model, while the design of a larger, fully traversable turret fitted with a 75mm gun was figured out, and the molds for a cast hull were developed. The M3 only ever managed to bear a sponson-mounted 75mm gun, and the turret was instead fitted with a weaker 37mm gun, with a hull consisting of simple, flat panels riveted together. This gave the 75mm gun the space it needed inside the hull, which was not available in the small turret. These design trade-offs disadvantaged the M3 greatly. If the crew wanted to fire the main gun over a sand or earth bank, they would be forced to fully expose the hull of the tank, and the entire tank would have to turn to aim the main gun, making the main gun clumsy and slow to control. The Americans were well aware of these design issues and were busy designing the M3's replacement even before the M3 entered production. This replacement would eventually become known as the M4 Sherman, the most produced Allied tank of World War II and the workhorse of the front line. While the M3 was never intended to be a long-term solution, it did influence many of the design decisions for the M4 Sherman. The M4 and M3 shared the same vertical volute suspension system, which used coiled sheet spring steel. This structure allows the coils to slide past each other, opposed to typical helical springs which hit a limit in compression when the coils contact each other, allowing the sheet metal spring to tolerate heavier loads in a more compact space, while being easy to maintain and replace. The lessons learned from the past year of the war taught the Ordnance Department that the new tank would have to be both fast and easy to produce. Taking lessons from the American automotive mass manufacturing industry, Chrysler, Ford, and General Motors all contributed to its manufacture. The engineers of the Sherman wanted all parts to be standardized so each unit could be simply and hastily assembled. These parts would also need to be simple to remove, so the M4 could be repaired in a combat situation with minimal delays. The bogies, which were sets of rubber road wheels that transfer the weight of the tank to the track, were bolted to the hull so that they could be removed with ease for repair. The M4 finally fulfilled the Americans' desire for a 360-degree fully traversable 75mm gun. The turret itself was made from a single cast part, rounded to deflect incoming rounds, and bolted to the turret ring. They fitted the turret with a single-axis gyro to stabilize the gun, allowing it to fire with greater accuracy while in motion. But with the relatively low muzzle velocity of 610 meters per second, it diminished the effectiveness of the turret and would be the basis of most problems the M4 faced in the later years of the war. The main weapon was, however, complemented by a 50 caliber machine gun mounted on top of the turret, with a coaxial 30 caliber machine gun and another 30 caliber gun operated by the bow gunner, making it a formidable infantry support tank. Production was simple and in full swing by 1942. At the height of production, one M4 Sherman rolled off the assembly line every 30 minutes. Just as America revolutionized mass manufacturing with the Ford Model T, which I have covered in more detail in the past, America was now revolutionizing the production of armoured vehicles. And, thanks to the Lend-Lease Agreement signed in early 1941, America was allowed to export thousands of tanks to Britain and the Soviet Union. Most estimates of wartime production reached over 50,000 units, but the Sherman wasn't produced in just one model. Each new variant built upon those before it, most focusing on improving the engine and the method of construction for the hull. For example, early M4 hull designs like the M4A1 were constructed from a cast hull, where the entire hull was cast in a single block. This was a difficult process and required a lot of specialized workers and equipment, and was difficult to repair in the field. It was soon dropped in favour of a simpler welded design where the hull was constructed from multiple flat and casted parts welded together. These welds were a weak point in the hull, and these too were gradually minimised with additional armour plating and superior construction to reduce the number of welds needed. One of the largest problems that resulted in a major redesign was the flotation problem, where the weight of the tank was not being spread over a wide enough area. This increases the pressure the tank will exert on the ground and thus make it sink further into the ground, increasing both the power needed to move and slowing it down, or worse still, getting stuck completely. To deal with this problem, some Shermans were fitted with track end connectors, called grousers, to increase the track width and thus decrease the ground pressure. A more significant design change was brought in 1944 with the introduction of a horizontal volute spring suspension. This, as the name suggests, moved the springs from a vertical to horizontal position, which reduced their height and allowed for the addition of a hydraulic shock absorber to smoothen the ride, and reducing the stress on the springs, which had a notoriously short life. The road wheels were now placed in parallel pairs, which allowed the track to increase in width to 0.58 of a metre, a massive increase in track width that drastically decreased the tank's ground pressure and thus increased its mobility. Other changes were made to improve the survivability of the M4 as a result of horrific lessons learned on the battlefield. The Sherman initially had 57-degree frontal armour, forcing the designers to implement tiny driver and bow gunner hatches. These hatches were far too small and made evacuation procedures difficult, made even worse by the fact that a large amount of ammunition was stored in the vulnerable turret, which often cooked off when the tank was hit, resulting in horrific fires. In late 1943, changes were made to improve the crew's chances of surviving after a critical hit. The armour angle was reduced to 47 degrees, providing more space to incorporate larger hatches. The majority of ammunition was also moved to the floor of the tank, where it was better armoured and less likely to catch fire. They also implemented wet storage, where each shell was separated by canisters filled with a gel-like substance made of water, antifreeze, and a rust inhibitor. If the ammo rack was hit, these containers would be pierced, releasing the gel, which would cool and quench the rounds. At this stage, the Sherman was a formidable foe for any Panzer tank. However, as the war progressed, newer and stronger German Panther and Tiger tanks entered the fray. To increase the M4's chances against these advanced German tanks, a final major redesign was introduced with the inclusion of a more powerful 76mm gun, bringing us to perhaps the best M4 variant that fought in World War II, the M4A3E8, or the Easy 8, which incorporated every improvement I've mentioned in this video, making it a formidable opponent for any German tank. This was just one of many Sherman variants that entered the fray with specialized weapons. Some were fitted with rocket tubes, which were rotated with the turret and fired in a barrage at soft targets. Others were fitted with flamethrowers, while some took on roles as frontline workhorses, being fitted with bulldozer blades and hedgerow clearing tools to clear a path for other vehicles and infantry. Others were modified with flails to clear minefields, designated as the Sherman Crab. This was a tremendous sight during D-Day operations, with the chain swinging widely around, striking the ground with a sickening sound for any onlookers. Occasionally, the chains would break off after successfully detonating a mine, forcing any nearby infantry to duck for cover. 290 Shermans were modified for the amphibious assault of Normandy, called the DD tank. These Shermans were fitted with rear-mounted propellers, which diverted power from the tracks using a bevel gear, which was the origin of the DD suffix, standing for duplex drive. They were also fitted with a folding canvas screen to increase the buoyancy of the tank and allow it to wade into shore. Despite showing itself to be an incredibly capable machine, the Sherman has a bad reputation in some circles. The old myth that it took 5 Shermans to defeat 1 Tiger, as perpetuated by the movie Fury. It shouldn't be a surprise that a medium tank like a Sherman would be at a disadvantage to a defending heavy tank, but this statistic is simply untrue. The Allies were also at a huge disadvantage with getting larger and heavier tanks into mainland Europe, where Germany could easily transport these vehicles over land immediately out of the factory. These World War II logistics are one of the most fascinating subjects I've ever encountered, and so I have decided to create an entire series dedicated to exploring the logistics and planning that went into D-Day and other battles of World War II. Starting with the first episode exploring how and why the Allies chose Normandy as a landing location. That series will be made with the support of CuriosityStream, a subscription streaming service with thousands of documentaries and non-fiction titles, and will debut next month on Nebula, a streaming video platform built by and for independent creators like Tierzu, Lindsay Ellis, Minute Physics, Wendover Productions, and loads more. Where CuriosityStream is all about big budget non-fiction videos, we're building Nebula because we want a place for educational creators to try out new content ideas that might not work on YouTube, especially stuff that might get demonetized like a war-related series. CuriosityStream loves independent creators and wants to help us grow our platform, so they're offering Real Engineering viewers free access to Nebula when you sign up to curiositystream.com/realelengineering. By signing up for CuriosityStream, you'll get access to thousands of documentaries like this one called Plane Resurrection that details the restoration of World War II era planes, and you'll get access to the first episode of my new channel, Real Science. We already have some fantastic original series on the platform, like Grand Test Auto, a car review show from my friends JT from Second Thought and Joseph from Real Life Lore. By signing up to CuriosityStream, you will be helping not just me, but the entire educational community, as we work together to build a place where we can create content like my Logistics of D-Day series that would just be too risky to rely on YouTube. As always, thanks for watching, and thank you to all my Patreon supporters. If you'd like to see more from me, the links to my Instagram, Twitter, subreddit and Discord server are below.